Today we're going to learn about microcontrollers and embedded systems. I did a poll on Instagram a while ago asking if you'd be interested in learning about hardware development. I was quite surprised because I got a really overwhelming response, with most of you being very interested. I was quite happy about that because hardware is one of my favourite things to work on, hence the channel name, but ironically I haven't actually done much hardware work on this channel. The main reason I've kind of avoided it is because generally it is quite difficult, and I didn't think many of you would be that interested in it. But you do seem kind of interested to learn, so I thought I'd create this video and see if anyone finds it useful. So going into this, one thing I didn't want to do was just dive straight into programming tutorials, mainly because hardware is a very complicated field and it can be quite tricky to learn, especially because a lot of people will skip over the basics. As with anything, you always want to get the basics down first as a good foundation and then build off of that. So as a starting point, I thought I'd create this video as an introduction to microcontrollers and embedded systems. I'll cover what they are, where they're used, and why they're useful. Hope you enjoy it. Alright, so you can see in front of me here I have a few different boards. Each of these boards has a microcontroller on it. They come in all different shapes and sizes, but generally they're easy to spot. The chips are actually these black devices here in the middle of the boards. The boards also come in many different shapes and sizes, and you can see that around the microcontroller we generally have a lot of other components, and they're called our peripherals. Before we talk more about these boards, let's go a little bit deeper into microcontrollers and embedded systems. What are they and what do they do? A microcontroller is a chip optimized to control other electronic devices. So you can almost think of it like the brain of a system. Kind of similar to the microprocessor you'd find in a desktop PC, but with a few very key differences. Microcontrollers are intended for use in very specific applications, whereas desktop computers are designed to multitask and run complex operating systems. There are three main elements that make up a microcontroller: CPU, memory, and I/O, or input-output, to connect to our external peripherals. The interesting thing about microcontrollers is that they actually have all three of those components all built into a single chip. This makes them extremely useful for smaller devices that we tend to call embedded systems. You've probably already heard of IoT or Internet of Things, and that whole idea basically stems from these kind of devices. The idea behind IoT is to have all these individual devices all connected together and communicating. So what classifies as an embedded system? Embedded systems are all around us, and it's funny because in the world today we tend to take everything for granted. Something like this TV remote, for example, most people are just going to grab it, use it, and not really think too much about what's going on inside. But a lot of effort goes into something even as simple as this. And that's what I love about electronics and embedded systems. There's kind of like this whole other world going on underneath what we see at face value. When you dive into it and start asking all these questions about how things like this work, you start to become a lot more grateful for all the technology we have today that makes our lives so much easier. So an embedded system is a digital device that is dedicated to a specific task. So for example, this TV remote is an embedded system. It has only one job to do, which is to send frequencies to the TV so that you can control and use it. This PS4 controller is also an embedded system. It also only has one job to do, which is to send your user input data to the PS4 via Bluetooth. An example of something that isn't an embedded system would be your smartphone or desktop computer. Smartphones and desktop computers run on complex operating systems that are generally designed to multitask. Your smartphone, for example, can be whatever you want it to be. You can play games on it, you can phone people, you can text people, you can use the camera, you can browse the internet. It has so many different uses that it's not considered an embedded system. Other examples of an embedded system would include digital watches, microwave ovens, washing machines, and the list just goes on and on. The important thing to remember though is that at the core of all these devices is a microcontroller, just like the ones we're looking at here. A microcontroller on its own isn't very useful, so let's talk a little bit about peripherals. What classifies as a peripheral? A peripheral is any electronic device or component that's external to the microcontroller. Notice on these development boards we have a lot of other components and ports around the outside of the chip. These ports and components all connect to the tiny pins on the chips, and we can use these ports around the outside to connect our microcontroller to external devices and peripherals. I have a few devices here that would be considered as peripherals. The simpler peripherals are things such as keypads, LEDs, microphones, buzzers, and again the list keeps going. But then you can have more advanced peripherals such as integrated circuits, sensors, or LCD displays. These type of peripherals will use communication protocols such as I2C or SPI. But that's a topic for another video. You can see here we've got two LCD displays, both different sizes. We've got sensors. This is an accelerometer gyroscope. This is an ultrasonic sensor. This is a speaker. And obviously this is a tiny little 5-volt fan. All of these are classed as peripherals because they're external to our microcontroller. And we can use our microcontroller to control and talk to all these different devices. These kinds of boards that we're looking at here are designed for testing and development purposes. If, for example, you wanted to develop your own alarm clock, you would first build and test the system on one of these boards before you go ahead and create a custom printed circuit board. These boards are generally quite big, but you actually only need the chip and a few other components to run an embedded system. The manufacturers generally add in a few more components for you so that you can experiment and play around with stuff that already exists on the board. For example, if we wanted to interface to this accelerometer and gyroscope, we would have to connect all these pins up to some of our external pins on the board, and then we could use a communication protocol called I2C to communicate with this other device and fetch information from it. These two boards here are Arduino boards, and they both contain 80 mega microcontrollers. Now personally, I don't really regard Arduino as a real hardware development platform. The software tools are very limited, and honestly the boards are aimed at kids or hobbyists who are just looking to learn and play around with really basic electronics. They're great boards if you want to prototype something super fast, but from my experience in industry, if you're serious about learning hardware development, you'll want to stay away from Arduino and go with something that's a little more capable and just more respected in the industry. These two boards here were created by ST Microelectronics, one of the most reputable semiconductor manufacturers in the world. Both boards have ARM Cortex M4 microcontrollers that are industry standard and packed full of extremely useful features. This Nucleo board has a smaller 64-pin chip, whereas the F4 Discovery board has a larger 100-pin chip. I think it's fair to say that the 64-pin chip on this board would cover 90% of projects, just because you're never really going to use all 64 pins. Unless you're building a really advanced embedded system, in which case you'd want to use a more powerful chip with more capability, so you'd go for something like this one. It really does come down to personal preference, and there are just so many options out there for you. You'll also notice that the STM32F4 Discovery has more peripherals on board for you to play around with. It has an accelerometer and a gyroscope built onto the board. It also has audio output. It has USB on the go for file storage and data transfer, and so many of these GPIO pins for you to connect up to your other peripherals. You can also configure these pins in a very flexible way, and we'll cover that in another video where I talk you through some of the software on how you set up these chips. One of the things I love most about these STM32 boards is that they come with a debugger already attached to the board. And you can see the debugger here at the top of the board. This means you can actually breakpoint and step through your code, which means you can debug properly. Whereas on the Arduino, the only real option you have for debugging is to print to the console, which is honestly not good. What I like about ST especially is that they're one of the few manufacturers out there that provide good documentation and resources for you to use. That's really important because hardware development requires you to read through lots of data sheets on how to actually program these chips. The chips are so advanced and have so many features that the programming manuals and data sheets provided by the manufacturers can often be, up to 1,000 pages long. Don't let that put you off though. It's actually a really good thing because most manufacturers sometimes produce a device, they ship it, and their documentation is really poor, and you're kind of just left to figure it all out by yourself. Definitely not the case with ST though. Their documentation is awesome. So now that we know a bit more about microcontrollers, embedded systems and peripherals, you might be thinking, well, what can we actually use all this stuff for? And the answer to that question honestly is anything. You're only really limited by your imagination. Provided you have all the hardware that you need and enough power, you can create anything you want. I recently did a project where I designed and 3D printed my own RC car. For that project, I used one of these STM32F4 Discovery boards, and using just one of these, I was able to control all the hardware, and that was quite a complex hardware project. Adding a microcontroller to your projects is just a way of adding some automation and intelligence. Let's look at a very simple example of how we can use microcontrollers to our advantage. I've built this really simple LED circuit. We've got 5 volts coming into the switch, and when I push the switch, current flows through the resistor, which lights up the LED. Now if I wanted the LED to flash every second, I could do this by manually pressing the button every second. While this does work, it isn't very efficient because I'd have to sit here all day and keep pushing this button. Wouldn't it be great if we had something that could flash this LED for us at 1 second intervals? This is where your microcontroller comes in. To tell a microcontroller what it needs to do, you have to write some firmware. Generally, this firmware will be written in embedded C programming language. After writing a program, we can flash it directly to the memory of the microcontroller, and then whenever we power it up, it'll continuously run that code in a loop. I've written a simple program that toggles this LED on and off every second. As you can see, when I plug in the USB, the microcontroller is running the code and it's completely automated this task for us. Obviously this is a very simple example, but hopefully it sheds some light on just what's possible by adding a microcontroller to one of your projects. One of the reasons I enjoy working with these devices so much is that you literally have the freedom to create whatever you want. All you need is an idea or a problem that needs to be solved, and when combining this kind of skill set with CAD and 3D printing, you can create some really impressive prototypes. So going forward, I'm going to start making some tutorials and mini projects around these 2 boards. This is the STM32 Nucleo-64 and this is the STM32F4 Discovery. I'll leave links to both of these boards down in the description below if you're interested in getting hold of them. You can pick up both of these boards here in the UK for around £25. And honestly, it's one of the best investments you could ever make if you're interested in this kind of stuff. I'll also be giving away one of these Nucleo-64 boards to one of my website members who help support the channel. So if you're not already a member, I'll leave a link in the description below where you can join up. Any support is massively appreciated and all gets reinvested back into this channel. So that's it for this video. As always, I hope you learned something. Let me know what you think in the comments below and I'll see you in the next video.